Students, in the last lecture I was discussing about the special cases of graphical method, and I discussed about multiple optimal solution in graphical method, where in the solution you will get two or more than two coordinate points or x1 x2 variable points for the maximum z or minimum z. Now in this lecture I will be discussing the remaining cases, special cases of graphical method. So the first one is no optimal solution in graphical method. So for this, let's take a numerical, that is maximization of objective function is equal to 3x1 plus 2x2 subjected to the constraint equations x1 plus x2 less than or equal to 1 and x1 plus x2 greater than or equal to 3 and x1 x2 greater than equal to 0. So here the objective function is z is equal to 3x1 plus x2. And now for solving this method for solving this linear programming problem using graphical method, we'll convert the constraint equations, inequality constraint equations into the equation form. We'll find the x1, x2 points for that equations, and we'll plot the lines and we'll find the feasible region, same as we do in the graphical method. So after converting the inequality constraint 1 into the equation form, and after putting x1 is equal to 0 we'll find x2, and after putting x2 is equal to 0 we'll find x1. So we'll get the points x1 is equal to 0 and x2 is equal to 1, and x1 is equal to 1 and x2 is equal to 0. These 2 points we got for the equation x1 plus x2 is equal to 1. Similarly, we'll convert the inequality constraint equation x1 plus x2 greater than or equal to 3 into the equation form, that is x1 plus x2 is equal to 3. Now we'll put x1 is equal to 0 and find x2, and put x2 is equal to 0 and find x1. So after putting this thing, we found x1 is equal to x1 x2 is equal to 0 3 and 3 0. We got 2 points for x1 x2 for the equation x1 plus x2 is equal to 0. Now we'll plot these points on the graph. So here the horizontal axis is x1 and vertical axis is x2, and after plotting the equation x1 plus x2 is equal to 1 using the points 0 1 and 1 0, we got this line. And we'll plot the points 0 3 and 3 0 for the equation x1 plus x2 is equal to 3, we got this line. Now to find the shaded area, to find the region for the inequality constraints, what we will do, we'll put x1 is equal to 0 and x2 is equal to 0 in the inequality constraint equations, and we'll see whether it gets satisfied or not. If it gets satisfied, then the region will contain this 0 0 coordinate. If the inequality constraint doesn't get satisfied, then the region will not contain 0 0 coordinates. So first x1 plus x2 is less than or equal to 1. So if you put 0 0, we will get 0, and 0 is less than or equal to 1, which means inequality constant equation is getting satisfied for 0 0 coordinates. So for the line x1 plus x2 is equal to 1, the x1 plus x2 less than or equal to 1 region is this area. It is this area. And for x1 plus x2 greater than or equal to 3, for finding this region, so this is the line x1 plus x2 is equal to 3. We'll put x1 x2 is equal to 0 0 in this inequality constraint, and we'll get 0 which is greater than or equal to 3, which means the inequality constant equation doesn't get satisfied and the region will not contain 0 0 coordinates, and so x1 plus x2 greater than or equal to 3 is this region. Now these are the two regions. This is one region and this is another region. So this region is only up to this point because we know x1 and x2 is greater than or equal to 0. So we are getting two shaded area which are not overlapping. Whenever we get any shaded area which are not overlapping, this means the linear programming problem has no feasible solution, because we are not getting any feasible area, any overlapping area. So this type of problem will not have any feasible solution. So this is no optimal solution type linear programming problem. The next case is unbounded solution in graphical method. So in unbounded solution, let's take a numerical. Maximization z is equal to 3x1 plus 2x2 subjected to the constant equations x1 minus x2 less than or equal to 1, x1 plus x2 greater than or equal to 3. So if we want to solve it using graphical method, what we need to do, we need to convert this inequality constant equations into the equation form, and then we'll find x1 and x2 points, we'll plot that on the graph paper, and we'll find the feasible area. So converting the first inequality constraint equation into the equation form, we get x1 minus x2 is equal to 1. Now for getting the points, for plotting this x1 minus x2 is equal to 1 equation in the graph paper, we need points for x1 and x2. So we'll find points first by putting x1 is equal to 0, we'll find the point for x2, and by putting x2 is equal to 0, we'll find the point x1. So after putting this, we got two set of points, that is 0 minus 1 and 1 0 for x1 x2 for the line x1 minus x2 is equal to 1. So plotting these points on the graph, will get 0 minus 1 and 1 0 on the graph, will get the line for x1 minus x2 is equal to 1, which is the line this. Similarly, we'll plot x1 plus x2 greater than or equal to 3, this inequality constant on the graph. So for that, first we need to draw the line, plot the line, and then we'll plot the region. So the converting this inequality constant into the equation form, that is x1 plus x2 is equal to 3, we'll find the set of points for x1 and x2 which will satisfy this equation. So putting x1 is equal to 0, we get x2 is equal to 3, and putting x2 is equal to 0 in this equation, will get x1 is equal to 3. So there are two set of points, that is 0 3 and 3 0 for the equation x1 plus x2 is equal to 3. So after plotting these points, we will get this line. So this is the line for the equation x1 plus x2 is equal to 3, which has been obtained by converting this x1 plus x2 greater than or equal to 3 inequality constant into the equation form. Now we need to plot the regions. So x1 minus x2 less than or equal to 1, the line is x1 minus x2 is equal to 1 is this line, as I have told you. And what is the region? Which is the region x1 minus x2 less than or equal to 1? For finding the region, we'll put 0 0, x1 is equal to 0, x2 is equal to 0 in the constant equation x1 minus x2 is equal to 1, and we'll see whether the constant equation gets satisfied or not. So after putting 0 0, we'll find 0. So 0 is less than or equal to 1, which means that it is getting satisfied. So for this line x1 minus x2 less than or equal to 1, region is this. So the region is this. Now if we need to find the region x1 plus x2 greater than or equal to 3, we'll plot the line x1 plus x2 is equal to 3. So we have plotted the line as I have told you now only. Now for finding the region, what we will do, again we'll put x1 x2 is equal to 0 0 coordinates in this inequality constant equation, and we'll see whether the constant equation gets satisfied or not. So after putting x1 is equal to 0 and x2 is equal to 0, we'll get 0. So 0 greater than or equal to 3, which is false. So means the inequality constant equation does not get satisfied for x1 and x2 is equal to 0 0. So means the region is that region which does not contain 0 0 coordinates. So this is this region. So ultimately the overlapping area is this. This is the overlapping area. So it will keep on increasing. As we keep on continuing the line, the overlapping area will keep on increasing. So this type of solution is unbounded solution. So here the maximum value of objective function occurs at a point at infinity. Hence this type of problem is unbounded solution, means there is no limit. It will keep on increasing. the feasible region keeps on increasing. So these were the special cases in graphical method which you will encounter, and this is all about the graphical method. I'm ending this class here. Thank you.